In this tutorial, I am going to explain how the modeling of the joints is to be carried out in SAP 2000. If it is a steel frame, maybe a truss, so in that case, the joints are modeled as a pin connected. But if it is a RCC joint, then beam column joint, most of the times, so we have the option, either we can give the rigidity, complete rigidity to the joint, or we can give some partial rigidity to the beam and column joint. So based on our assumption, or based on the way of modeling of the beam and column joint, the results also differs. So there is a variation in the results. So variation in the results in the sense the internal forces as well as the deflection deformation also there is a variations. So through an example in SAP 2000 software, actually I will demonstrate how the modeling of the beam and column joint affects on the variation in the result. Now in the SAP 2000 program software, so there are two commands for modeling of the joints. So first it is called as the end offset command. First, it's called as the end offset command, and second is called as the panel zone command. About the end offset, so which length in the joint is called as the end offset. Okay, so that I will explain first. Okay, now in this case, in the first figure, this is the center line of the column and this is the center line of a beam. Okay, now distance between the center line of a column to the face of the column, inner face of the column. So this distance is called as the end offset. So this is end offset for the beam. Similarly, this is the center line of the beam and this is the bottom face of the beam. Okay, and whatever this distance is the end offset for the column. Okay, so these are the two end offsets. And the rigidity, whether it is a complete rigidity or partial rigidity, so we have to assign the rigidity to this particular end offset. So we have to assign the rigidity to this end offset for the beam and end offset for the column. So here in the figure number 3 here, so end offset, this end offset for the beam. So complete rigidity is given, that is 100% rigidity is given to the end offset for the beam as well as for the column. So if the complete rigidity for the beam as well as for the beam for the column is given, then it is considered as this joint will behave as a 100% rigid joint. Okay, it is 100% rigid. So in that case, the rigid zone factor is taken to be equals to 1. In the case of partial rigidity, suppose the 50% we have to make the joint as the rigid, 50% rigid. So in that case, how the modeling should be? So in that case, the figure number 2. So this is the total end offset. This is the total end offset for the beam. Out of that, if this is the total length of the end offset of the beam, out of that, the rigidity is assigned only for the 50% length. So from this to this is the 50% of the total length. So the rigidity is to be assigned, and similarly for the column. So column end offset is total, is the column the end offset length. Out of that, assign the rigidity to only the half portion. Okay, so if we do the modeling like this, then it is said that the joint is partially rigid or the joint is 50% rigid. Most of the codes recommends that if there is a RCC frame is there, then partial rigidity is to be assigned to the beam and column joint. So therefore in SAP 2000 also there is a default value of rigid zone factor is equals to 0.5. Rigid zone factor is equals to 0.5. Okay, so this is about the end offset, that is by using the first command, the modeling of the joint. So in the second second command, what is called as the panel zone, using panel zone command. So in this case, this is called as a panel zone. Okay, the complete joint, it is called as a panel zone. And in the panel zone, some rotational spring is assigned. And rotational spring, so it is assigned because it exhibits very nicely, it exhibits very effectively the shear deformation of the joint. And therefore, a rotational spring is to be assigned. And whenever we provide a rotational spring, the joint becomes more flexible. And the frame behavior also becomes to more and more flexible. So this is the second way of the doing the modeling of the beam and column joint in the case of RCC frame. Now it is a user's this thing, option, that is how actually he wants to model the particular joint. But the most of the developing countries code recommends that whenever the RCC beam column joint is there, so it should be modeled as a 50% rigid. Now in the SAP 2000, by using these both commands, that is offset command, end offset command, and by using panel zone command, how we'll see how to do the modeling and how the results are varying. Okay, now this is a so here I have taken a 2D frame. It is a 2D frame and it is a 6-story 2D frame is there, and it is RCC frame. It is RCC frame, and these are the different joints are there. Okay, and already as I said in the SAP 2000, this joint is modeled with a rigidity equals to 0.5. So zone factor, rigid zone factor is kept as a 0.5. This is default value. Okay, now in the first case, so in the first case, now rigid zone factor, if it is kept as a 0, rigid zone factor is kept as a 0, then what is the result that we'll see. So rigid zone factor equal to 0, it means that so the connection, that joint is provided with no rigidity, Okay, so its meaning is like this. So we'll keep the zone factor to be equals to 0. So how to? So by using end offset command. So how to use the end offset command for the modeling of the joint? That's it. First of all, select complete frame. Select complete frame. So all the joints as well as all the elements get selected. Okay. Then here assign, then frame, assign frame, and here the command is end offset. Here end offset. Okay. End offset. Then now the first option is about the calculation of the end offset length for the beam as well as for the column. End offset for the beam as well as for the column. Now, so here the option is first is automatic from the connectivity. So that is software automatically calculate itself the dimension of the end offset for the beam as well as for the column. By knowing the dimension of the beams and column, it automatically calculates. So usually go for the first option, that is automatically from the connectivity. And here rigid zone factor, we have to change only this. Now rigid zone factor in the first case will keep as a 0. Then apply and OK. Apply OK. Now the joint becomes flexible. Now we'll do the analysis. Okay, and for to see the variation in the results, we'll see only the time period. And if there is a variation in the time period, so it means that same kind of variation will be there in other results also, internal forces and deformations. Okay, so do the analysis. So we'll run only the modal analysis because we are interested to see only the time period. Okay. Now, when the joint is modeled as a flexible, the time period is found to be 0.56. So this is our first model. Time period is equals to 0.56 second. Okay. Then now this is regarding the first one. Then in the second model, so the rigidity is provided to the joint equal to 50%. Okay, so that is rigid zone factor is kept as a 0.5. Okay, 0.5. And then unlock the model. Again, unlock the model, and again you just change the rigid zone factor. So here assign the frame end length offset, and that is kept to be equals to 0.5. Now it is a partial rigid. It is a partial rigid. The frame becomes little bit rigid. Okay, so therefore expected time period should be less than this. Now after the analysis, we'll see how much it is coming. How much it is? 0.53. So it will be little bit reduced. So for the second model, where we have provided a partial rigidity, so the time period is reduced to 0.53 second. Okay, this is the second one. Okay. Then, and now in the third case, now we'll provide the rigidity equals to 100%. So rigid zone factor is equals to 1. Rigid zone factor is equals to 1. Okay. Then again, unlock the model. Unlock the model. Again, just change the rigid zone factor as a equals to 1. Equals to 1. So it means that the joint is completely rigid. So then apply and okay. Now the frame becomes more stiffer. The time period has to be reduced. How much it is coming? 0.50 it is. Now it is 0.50. So time period is reduced. 0.50. Okay. So these are the way of modeling of a joint using end offset command. So in the first case, the frame is, there is no rigidity is provided to the joint. It means more flexible, therefore time period is more. And in the third case, we have provided the joint to be a completely rigid. The frame becomes a stiffer, right? So therefore the time period is reduced to 0.50. Okay, so this is the first way of modeling. And second way of modeling is that by using the command, what is called as a panel zone. Okay, so what is that panel zone? Now to use that particular command, okay, essential thing is that please ensure that this particular zone factor, rigid zone factor must be equal to 1. So first of all, whatever the joints are there, so provide complete rigidity. Okay, and then use the command panel zone. Okay, so next is we'll unlock the model. Unlock the model. Okay, now we'll check this. How to check this? You just click on any member. When you click on any member, so whatever the properties we have assigned, so we can see these properties. So this is a this thing. It is a beam, and here we have provided end zone factor. How much? Here end zone factor is equals to 1. So it is there. So therefore, first of all, ensure this. And if this value is not equal to 1, okay, so then please make this first of all equal to 1. So that is ensure that joint is completely rigid. Okay. Similarly, we can check for the column also. So just click on the right click on the column, right click on the column. So here also the rigid zone factor for the column end offset. So rigid zone factor is equals to 1. So in this way also we can check the rigid zone factors. Okay. Then to use a panel zone command. So first of all, select complete the frame. Now this particular command, a panel zone command. So this particular command is applicable for a particular joint. Is to be applicable for the particular joint. So therefore, after selecting all joints, then go here assign, and here it is joint. Assign joint, and here it is panel zone. Here it is panel zone. Okay. So panel zone means so this is called as a panel zone. So in the panel zone, that is the joint portion. What is the material property? That is most important. What is the material property? And based on that, the modeling depends on that. So in SAP 2000, okay, so here whatever the different options you are seeing, so this is asking the information about the material properties in the panel zone. So most of these things, so we'll select the first, because if we select the other options also, the variation in the result is very small. There is no much more variation. So here, first option is that elastic properties from the column. So this is the panel zone. Above this, there is a column. Below, there is a column. So what is the elastic property of the column? Okay, above and below. So in the panel zone also, the material property is the same as that of the column above and below. So that is, column is considered to be a uniform, okay, through the joint also. So that is the option first. So we'll choose the first default option. So in SAP 2000, this is the default option, which is also a correct way of modeling of the joint. Okay, then say apply, and okay. Okay, so PZ in the sense, now the software automatically assign the rotational spring into the panel zone. Okay, into panel zone. Okay, now whenever we assign some springs in the joint, or it may be at the supports. Okay, so the behavior of the frame becomes more flexible. Okay, so let me see what is the time period comes in this particular modeling. Then do the analysis. So the time period is coming 0.53. It is 0.53. So it is a fourth modeling, say fourth model, it is 0.53. 0.50. Okay. So as compared to the third one, third is a complete rigid, 100% rigid. Then it is a 0.50. And this is a fourth is a, again it is when we provide a rotational spring. So that means, so this value becomes to the second one. Second is a partially rigid. Okay, it is 50% rigidity we have provided. So to provide a partially rigidity, so we can say that either we can use a end offset command by assigning the zone factor to be equal to 0.5, or by using a command panel zone. Okay, so both are giving the nearly the same results. So as I mentioned above also, so that is in many this codes, if the RCC joint is there, it is to be modeled with a the joints are to be modeled as a rigidity with a 50%. Okay, so this is in this way the modeling of the joint is to be completed. So for the variation, to see the variations, we have taken only the time period, and there is a variation. We found some variations. So the same kind of variations will be there. So if there are, in the case of the other results like internal forces, deformations, and like this. So therefore, the modeling of the joint is very important.